from Dr. Josep Maria Haro from the Parc Sanitari Sant Joan de Déu in Spain.
Thanks, Paula, for presenting me, and thanks for the invitation also to Jacques and the rest of the organizers. It's a pleasure for me to be here in front of you. Also my first time in Uruguay, so happy to visit the country. I'll be also talking about a couple of projects and actually explaining a more practical way of doing some of the things we have been discussing. So hopefully my presentation complements very well what has been already said. My life ran a little bit in parallel with Jorge's life because I also started medical school. At the second year of medical school, I moved to engineering, but it was only for 2 weeks. I came back to medical school, and then now I am a psychiatrist and an epidemiologist. My field of research is psychiatric epidemiology or epidemiology of aging. I also, besides the small period I was in the US, I only moved neighborhood in the city of Barcelona. So I'm also from Barcelona. So we've seen that in personalized medicine, what we need to do is to understand what predicts the course of the disease for the individual, no? And to achieve this personalized, this personalized healthcare. And for doing that, we rely on data from many sources, epidemiological databases, electronic health records, clinical trial data, genomic data, both at the individual and population level. And getting all this data and being able to analyze it together requires a large databases. The more variables you want to take into account, the more observations you need. So this requires this merging of the databases, and this is what I will be talking about today. This has been done in the past. We've seen examples from genetics. They were the ones who first created large databases. In genetics, somehow it's easy in some way. For example, this is a recent study that conducted at GWAS on individuals with anorexia nervosa that got almost 17,000 cases of a quite unusual rare disease. This is hopefully not very frequent in the population, and this was done by putting together data from 33 studies. GWAS have not produced as much as was expected, but what we have seen, and Jacques already explained, is that in the area of genomics, in the area of cancer, pharmacogenomics is where precision medicine has made more developments. But also merging of databases has also been produced in other areas. For example, this is like a meta-analysis and individual patient meta-analysis. That means putting together patient data from many clinical trials. In this case, were 11 studies analyzing how vitamin D deficiency and vitamin D supplementation could prevent fractures in individuals older than 65 years of age. And what they did was to analyze data from 31,000 participants, and they saw that the level of vitamin D in the plasma was highly correlated with the risk of hip or hip fracture or other fractures in the body. Also, in the epidemiological field, there have been efforts to put together different studies. This is a classical picture in which we see which is the risk of stroke mortality and for different levels of blood pressure, systolic and diastolic blood pressure, and for different age groups. And what these authors showed also is that you only achieve this precision if you are able to put together data from many different studies. And what they did was to put together data from 12 million person years. I mean, 12 million years of observation of an individual with 50,000 deaths. And actually what we see, and this is a plot presenting the number of studies published using data that harmonize data from different studies, no, we can see that this is an area which is actually rising very rapidly. There are many initiatives trying to do this. This is an interesting initiative. This is the International 100K Cohort Consortium. This is a consortium that was created a couple of years ago, made from different consortium that try to put together databases or cohorts with more than 100,000 individuals. When I first knew about that, I thought that there would be a few of them, no? A few studies that followed more than 100,000 people for several years, but actually in the meeting last year, there were like about 70 studies that had been already identified. So this is like a map of the world. In many developed countries, there are cohorts, no? In the UK, but many in the US and many other places in Europe, they have studies including more than 1,000 people followed over time. So if we want to be able to create these large data sets, we may need to integrate data from different sources. No, we have seen before that we need to get data from behavioral aspects, genomics, health records, environment, metabolomics, transcriptomics, also medications or adverse events, in order to produce these to advance in precision medicine, in personalized medicine, specifically in trying to predict risk. We've seen this example of dementia very recently. Also to be able to stratify diseases and make more specific patient groups, and also optimize treatments. But this is not easy, since there are many challenges in putting together data sets coming from different studies. No? Usually, when data come from different sources, they have different structures, or some of the data may not have any specific structure. There are many measurement issues. We've seen the problem of missingness of data. No? Many times the data is also inaccurate, or there is people who report data also may not be precise. In general, we lack information on the social determinants of health. We have much more developed getting data from the individual than from societal groups. That's a reality, and we know that social determinants of health are very important in disease origin and course. We have privacy and security issues, and this is not cheap. Also at the data integration level, we have many times studies have heterogeneous data syntaxes and data structures. The data is stored in different ways. There are different modes of accessing to that. Also, there are many ontologies, no? Many classification systems that are used for different type of uses or different type of variables. And we also have problems many times with semantic data integration. We don't exactly know, or maybe things may not mean exactly the same. Even the same words may not mean the same thing in different environments. So, given all these issues, the European Commission published a call. I mean, the European Commission has several programs trying to support research. One of the programs is called Societal Challenges, and what this program does is to identify societal challenges in health, but in other areas of knowledge, and then publishes calls so that consortiums of investigators can propose a solution to those. No? This is what they call a coordination and support action. That means that they request a proposal trying to get a consensus from the scientific community trying to solve a problem. So this is not a research project, but a consensus exercise. And what they asked in this project was to make a proposal of how we could maximize the use of cohorts of population patient and clinical trial cohorts, and this is important in the sense that most of the integration occur at the same level, no? I mean, we have seen integration of population cohorts, patient cohorts, and clinical trial cohorts, but not cohorts of the theta levels, and this is actually a challenge. In order to accelerate the development of personalized medicine. And with this, we need to try to integrate data coming from the environment, social aspects, occupation, lifestyle, and also individual characteristics. We sent a proposal also with CRIN, with Jacques Demotte, and we were successful, and we started about one year ago, not a little bit less than 1 year ago. Our plan in this project, and for me it's very important to be here to tell you this, is not to reinvent the wheel. I mean, of course, what we will do is to try to put together experts in the different areas to get advantage of the knowledge and to be able to propose something that will take advantage of all these things that have already been done. Actually, this is what we have been doing for the first year. We have been trying to get information on the different initiatives, putting together all these data sets. And for the next year, what we will do is to have meetings with them in different areas that we have identified where challenges exist, and try to advance in a solution of this problem. No? So anyone who would be interested in this, please contact us or contact me. I mean, I forgot to give the email, but Paula will be happy, hopefully, to send it to you. And hopefully we can incorporate that. That could be a very interesting European-Latin American collaboration, and actually very fruitful for us. The first thing we have learned is that the different areas also use different languages. So in the area of population or patient cohorts, we talk about harmonization of cohorts, but on the area of clinical trials, we may talk about individual patient meta-analysis, which is actually something similar. It's putting together data coming from different studies and different, and we have also heard about federated analysis and all these funny terms that I didn't know what they meant a few months ago. So for the rest of my talk, I don't know how much is. Okay, I'm fine. I have 10, 15 minutes. Okay, so for the rest of my talk, I will talk about another project that we have been doing, which is the Ovilus Project, in which we harmonize data coming from very different population cohorts. So harmonization, and this is the Google definition, the meaning is combining data from different sources to provide a comparable view of data from different studies. So what we want to do here is to put together data coming from different studies. This can be done in two ways. One is the retrospective harmonization. It means you do this with studies that they have already finished, or you could do prospectively. I mean, you can like set the scene so that this is easily done in data that will be collected in the future. The project I will talk about is Ovilus. It's one of the many studies that have done harmonizations, and we did retrospective harmonization. The objective of Ovilus was to understand, or is to understand, the objective, the project is still going on, is to understand which are the determinants of healthy aging. And by doing so, for doing so, we have harmonized, we have already finished that. It took us more than 3 years, so it's time consuming. 20 longitudinal studies of aging. We are now on the analyzing which are the patterns of healthy aging trajectories and also the determinants of these trajectories. We want to use also this to make a new definition of old age. You know that we define old age as a chronological age, above 65 years, but this was actually established at the beginning of the 19th century when the expectation, the life expectancy was less than 50 years. So we need to, and when most of the jobs were very physically demanding. So we need to reconceptualize what an old person means, and hopefully before I get 65, we will be able to do that. And also we want to translate these findings into policy recommendation. We have some micro-simulation analysis in the project that we are also conducting. So the first objective was to create this harmonized data set, including data from physical and mental health of individuals, but also lifestyle, disability, quality of life, well-being, family and social environment, participation, and use of health and social services. We did this retrospective harmonization, getting data from different studies that had different designs, research questions, procedures, also timelines of the evaluation. And we use a methodology that was initially developed by Maelstrom Research. Maelstrom Research is I don't know if you already know, it's a Canadian consortium. And the origin of Maelstrom is quite funny. The Canadian government decided to conduct a survey in the whole country. So you know that Canada has different states. So they got together and all of them decided of a questionnaire to be administered in each of the states for this survey for the country. They went to the state, they conducted the survey, they came back, and they had modified so much the questionnaire in the state that they had to create this Maelstrom research to harmonize the data back. Data that had already been agreed upon, but the country said, no, I want this question, no, this one is better. And so they had to spend several years putting things back together. So when you harmonize data sets, and I think this is valid for survey data, clinical data, one important issue is define the research question. We've seen that, and we'll see that some of these questions have thousands of questions. So harmonizing questions and understanding the meaning of those questions is almost not impossible, but you cannot do it manually, no? So it's important to define the research question so that you understand or know which variables you need for your study. So then you get the documentation and the studies where you get the data from. This is the first step, define the background. The second step is to evaluate the harmonization potential of each of these the studies. You need to create a data schema for each study. You need to identify the variables and see which of those variables could be suitable to be harmonized for your in your variables of interest. So you need to create this potential of creating the harmonized variables, and then you need to process data and estimate the quality of the data. There is also a software. This is a free software initially developed by Maelstrom Research that helps you doing that. It includes a web data portal so you can show the data you have. Mika, it's a program that allows you to describe the data set or create the study catalogs with all the different dimensions of the data, and then the variables that included in each of the dimensions, and then you have Opal to store the databases, the dictionary, and do the data harmonization. No, Opal can work with different programs. We have used R for this. We have already put many of the things available in the webpage of Athlos, the data sets, the variables that we have, the data sets, and the harmonization programs that I will explain you about in a couple of minutes. So the first step, very important, is to define this objective. In our case, we want to create a health metric. If we want to determine which are the trajectories of health, we need to have a single measure of health. And this is like one of the most important issues in the project. And this health metric is a combination of has variables from intrinsic capacity and functional ability. But we could have established other questions, no? Like to assess the role of nutrition on or other lifestyles on quality of life or health. I mean, and depending on this particular objective you set, you have to decide which are the variables you are interested in. So we selected about 200 variables to harmonize. 200 variables to harmonize times 20 studies, 400, 4,000. 4,000 times at least 2 assessments for each study, it's 8,000. So we had to harmonize manually 8,000 variables. So we have information on socio-demographic and economic variables, lifestyle, health status, diseases, life expectancy, physical measures, psychological measures, also cognitive function, laboratory assessment, social environment, and some administrative variables to identify the individual. So then we had to map each of these variables in each of the studies, propose an algorithm for the harmonization, and what we did was to ask each of the partners participating in the project to harmonize the variables in which they had more expertise. So you need experts in that area to be able to harmonize the variables. So what we did was to ask the partners, depending on their expertise, to harmonize the variables, and centrally we processed the data and created the harmonized variables. These are the studies we harmonized. I don't know, most of them include only a single country, except for some of them. SHARE is a very European-wide study. SAGE also includes the area from this WHO study, including area from many countries. But in total, there were like about 400,000 participants, a little bit less than that. And you see that this is the number of variables in each study, and there were studies with 43,000 variables. This one only had 100. It was a very small study, but there were studies with thousands of variables. As I said, we identified in each of the studies the variables we were interested in to create the harmonization. And then we created this harmonization algorithm in each of the variables. No? For example, this was depression. We decided to, because when you define the variables, you need to also decide how you define those variables and which are the categories of the different variables. So depression, we decided to classify yes, no, depression in the last 12 months, because this was the information that was more frequently assessed in the different studies. And finally, we try to assess the quality of the harmonization process. Like by, I don't know, this is the year of age, or this is the level of education. So we saw, and we compare these variables to the raw original variables. In this study, we have used R Markdown. Also to, I mean, we tried, I mean, this is a big effort, so what we want to do is to put this available to the scientific community. This is what we have started doing. R Markdown is a program based on R that produces a report at the same time that you run the program. So with this, what we do is to provide a report on what we are doing in the harmonization, and also the results of the harmonized variables. And we already published the first paper presenting this harmonized data set very recently, and now we are in the process of analyzing all this data. For example, this is the health metric we have created for the different studies. We see that the health, this was cut. The health metric decreases with age. This is how, which is the, see very well, I don't know, which is the, this is a survival curve This is a survival course of the individuals belonging to different strata based on the health metric. You see that individuals having a worse health score at baseline had a much higher mortality than those having a better health score, and this is time, so this is 5, 10, 15, 20 years, and this is the health score, this is the beginning everyone is alive, and then you see that the speed of the mortality depends on the baseline health metric. This is also how the health metric varies across the countries. And this is always in these international studies, analyzing country differences is very complex because there are many cultural issues also in answering the question. So it's difficult to understand. But here in the health metric, the best ratings were people from Switzerland, Japan, Denmark, Sweden, Netherlands, and in the lower ratings we had Ghana, India, Russia, South Africa, Poland. This is somehow some kind of validation of this metric because, except for some cases, it makes a lot of sense.